when we are dividing like bases, like we have right here, we end up subtracting the exponents, where we subtract the numerator by the denominator. So for instance, if I look at this general rule that I have right here, I have a to the b divided by a to the c. Since a and a are like bases, I would subtract b minus c to figure out what it is that I would get. So if I take a look at some of these examples that I have here, if I look at number 12, I see that I have x to the 6th over x to the 5th. That means I would do 6 minus 5, so I would get x to the 1st. Now, if you wanted to simplify that down a little bit more, you could just rewrite that as x, because you don't necessarily need that one as an exponent. Now, if we take a look at number 13, we have two bases, so we have to identify both of them separately. So if we look at the x, we have x to the 5 and x to the 2nd. So if I do 5 minus 2, I would get x to the 3rd for the first one. For my y, I have y to the 3rd and y to the 2nd, so I would do 3 minus 2, so this would give me y to the 1st. And again, I could simplify this down a little bit more by writing x to the 3rd y, because I don't necessarily need that one right there. I can rewrite it where I don't write that one. Now if I take a look at number 14, we see that we have coefficients out front here. I have this 32 and this 16. Well, coefficients are not bases. Coefficients are just coefficients. So we do exactly like what we would normally do. And in this instance, we would divide them. So we would do 32 divided by 16. Well, if we take 32 and divide it by 16, we would get 2. Now we look at our bases. So now I look at my x's. So I have x to the 5 and x to the 2nd, so this gives me x to the 3rd. And then if I look at my y's, I have y to the 5th and y to the 3rd, so that would give me y to the 2nd. So then my answer would be 2x to the 3rd, y to the 2nd. Now if we take a look at number 15, I see that I do have a base of x, but there is no other x, so x just becomes part of the answer. But if I take a real close look at my y's, something special is going to happen with my y's here. I have y to the 4th over y to the 4th. Well, anytime whatsoever I have y to the 4th divided by y to the 4th, or anything that's exactly the same exponent on top of each other, they're actually going to cancel out. And the reason why they cancel out is because the 4 minus the 4 is 0. You do not write 0 in your answer. So right here, we would just eliminate out the y's. So y is no longer a part of my answer. Now if I look at the z's, I have z to the 2nd divided by z. And even though I don't see it, there is an implied 1 right there for that z exponent. So I would do 2 minus 1. This would give me z to the 1st. So if I wanted to rewrite this, I could rewrite this as x z. Now let's take a look at number 16. Number 16, I want you to go ahead and put a star next to. Number 16 is special because, again, my bases are actually the numbers. Now, just like how we talked about before, the numbers don't change when they are bases. Just like how on my previous examples. For instance, take a look at number 12. X stayed X. Look at number 14. X stayed X, Y stayed Y. So right here, my bases of 2 and 3 are actually going to stay 2 and 3. So right here, if I look at my base of 2, I have exponents of 10 and 8. So if I subtract those, I would get 2 to the 2nd power. Now I'm going to multiply it by, and then if I look at my bases of 3, I have 25 and 17. So if I subtract that 25 and that 17, I would get 3 to the 8th. So I would have 2 to the 2nd times 3 to the 8th. Now number 17 and 18 are also very special. And that's because they are actually turning into algebraic forms or algebraic representations of these. So whenever I am looking at these kinds of algebraic representations, I still combine them like how I normally would. So for instance, on number 17, my y's are my bases, but now I'm going to take 5m plus 6 minus negative 2m minus 9. The easiest thing to do whenever you're given an algebraic representation like this is to actually write it out. So you would have 5m plus 6 minus, and then the whole quantity of negative 2m plus 9. And the reason why I recommend that you write it out is because this negative is going to distribute to both the negative 2m and the 9. And if you don't write it out like this, then you might forget to do that. So if we go ahead and distribute that in, we get 5m plus 6. This turns into a plus 2m, and this turns into a minus 9. So now if we combine like terms, 5m and 2m gives you 7m. And then 6 minus 9 gives you a negative 3. So 7m minus 3 becomes your new exponent. My base is y. My exponent is now 7m minus 3. Go ahead and try number 18, and let me check it.